Hello, Keith Rucker here at VintageMachinery.org. Well, it's been a little while since we started on a project here to do some repairs to this piece here, and I'll put a link in here to the video to let you guys take a look at what we started out with. But basically, this casting here is for a Delta grinder, and the original one had the ears broken off. They had welded on a plate on the bottom. It was a really not a very nice looking repair, and we wanted to get it back to looking a little bit more original. So the person I'm doing this for had another one that he had off of another model that we were able to copy the pattern for these ears, and we actually had these cast out of cast iron. And I've already got this piece prepped, and again, that's in a previous video, but now what we want to do is take these castings that we got, machine them to fit on here, and then actually attach them to this. So we'll probably braze them in place so that we can have a good permanent repair. So we're going to be working on the castings here to get them to fit the base that we've already modified, and that's what we're working on today. So again, this is what the original looked like with the ears, and the ears on this one had been busted off, and so we had these pieces cast to copy the originals, and this work was done in a previous video, and I'll put a link to it in case you want to go back and look at that. But basically what we're going to need to do is machine these to fit down into these slots, and then we will attach these probably with some braze, maybe some mechanical attachment as well, and get it back to where we have a nice repaired original. So first thing we need to do to these, I purposely, when I made the patterns to have these casts, I purposely made these a little bit oversized so I have plenty of material to work with. And the first thing we need to do is get a good clean edge on this outside edge right here. And I actually need to machine about 200 thousandths off of that to get everything to fit right. So we'll be going over to the milling machine now and milling that out, and then we will be milling a step in here to match this step so that this piece just kind of fits right down in there. Now to do this milling, I'm going to be using my mini pallet system that we built in a recent video, and this is actually the reason I built this mini pallet was for this job, although it's going to come in handy for a lot of things. So what I've done is I've just taken a couple of screws and put down into some of these holes, and this kind of gives me some setup guide. So if you see, that goes right up against that. It almost acts like a fence, and I'm going to do two of them at a time. One set up and just do them both. There's no reason to do these individually. They're basically both having the same thing done. When we get to cutting the steps, we may have to do some things a little bit specific for each one. I'm not sure yet. I haven't measured that far, but hopefully we can do everything in one operation, just go across them. So I've got those in there. Here's our hold downs, and again, I've already got them set up here, but this will just clamp right down into the table. Now, one thing I'm having to be kind of careful of here is I'm going to just set these up once, and I know my hand's in the way, I'm sorry. So let me kind of get that where I want it. And, you know, well, why aren't you clamping down here? Well, we're going to be milling down there, so I really need to do all my clamping on this little tang back here because our next cut's going to be all the way down in there, and I'm wanting to just set this up one time. So that's kind of the reason why. We'll clamp these down. I'm going to put 2 clamps on each one, and we'll be back in a minute to show you what it looks like. But we got everything clamped down now. I basically just used all my clamps. You know, some of this is probably overkill, guys, but I would just rather clamp it down real good. So we've got 3 clamps on the actual tab back here, and also put some on the ends. You know, with these stops behind it, the milling pressure will be kind of pushing into those, but it could also be pushing these side by side. They're both butted up to one another, and then I got these on the ends kind of holding it. So hopefully that should keep it in place. I mean, the only place that it can really go is out this way, and with the cutting pressure pushing it this way, I don't think that's going to be an issue. So this should be good. You know, again, I'm a little bit concerned milling cast iron. You know, is this going to be strong enough to hold down? Yes, I think it is. But I'm going to make sure that I'm not trying to take, you know, 100 thousandths cuts off of this thing. We're going to take some light passes and keep it manageable for the holding power that we've got on this. So I've got a Niagara cutter, 4 flute end mill in here, 3/4 inch diameter. I went down and basically just touched off. I just took my quill, touched off on the table, and then lowered everything down about 5 thousandths. So I got about 5 thousandths clearance down here where I'm not getting into my table. And even if it mills a little lip on the bottom, the way this is going to work out, it's not going to be in my way. It's not going to matter. So I'm, you know, the ideal thing with this table here is this is somewhat sacrificial. If you have to get down in this aluminum table, it's no problem. Next time you use it, you just face it off and go. But there's just not a need for me to do that right now. I've got my mill set on about 450 RPMs. What I'm going to do now is just come in here and just kind of touch off on this face. All right, we're touching right there. And I'm going to come out to the end. And I think I'm just going to do about, let's just do about 25 thousandths on this first pass. So that's about right there. And then lock my table down. And I'm going to see how it cuts. And we're just going to feed down through here. And I'm pretty happy with that. You know, I'm just going to take my time. We're going to work our way through here. So we're going to make several more passes and just take a total of about 200 thousandths out of there. So I'm going to go to 50 thousandths total on my DRO up here. Another 25 thousandths pass. And we'll make another pass down through here. All right, well, I've knocked these down to the thickness that I think I need. My initial plan was I wanted to do all this milling up on making the step in one pass, but after doing some measuring, there is some slight differences between one and the other, so I'm just going to go ahead and take these off, and we'll do each one individually on the next step. And I also want to take them off to go over there and do some measuring and just make sure I've got everything exactly like it needs to be. So we're going to go ahead and break this down now, and back in a minute. I'm set up now to go ahead and cut this step in here that I need to cut. And like I said, we changed our setup a little bit. Initially, I was going to do this all in one pass, but the dimensions are just a little bit different. So I'm going to do this in 2 separate ops for each one. And more or less the same setup as before. I've got my 2 pins in the back that I'm pressing that up against. I got these on the ends to keep it from sliding. I went ahead and put one in the front here that's kind of pushing it back. So really this thing kind of sits right down in here and doesn't move around a lot. Then we have the clamping pressure that's clamping it. So, you know, if this were to be a little bit loose, which it's not, there's really no way this thing's going to move because of all the pressure points around it. It's captured in there, which should give me a nice, good setup. So I think what we're going to do, I know I've already done this. I came in, we just touched off on the front. I know that I want to go 510 thousandths back, so we just moved it out using the digital readout. And then the depth needs to be 275 thousandths, and I just touched off on the top again. The depth isn't super critical. This one back here needs to be pretty close. And we'll just use a digital readout. I'm probably going to do about a 50 thousandths depth on these. I feel a little bit more confident with my setup, and so that's what we're going to do. So I'm just going to use the digital readout, and we will come up 50 thousandths. Right about there. And let's let it roll. So we've got these ears machined now, and they're pretty much ready to go on here to braze in place. So, you know, they just kind of fit in place. Now I purposely made this thick, and we're going to go actually mill all this flat later. But for right now, basically what I need to do is just get this thing held in place. And to get it started, I'm just going to lay a piece of metal across the top of this. The weight should allow me to at least get these things going. And once I get them tacked on here kinda with the braze, then we can move on. So I may see if I can clamp down on that. I got to figure out exactly what I'm going to do, but that's kind of what I'm going to hold in place, and we'll start putting some heat on it and brazing these up. Well, I changed my mind. I'm going to do it this way. I got these laying on some fire bricks, and this way the weight of everything kind of hold it in place. And we'll get it tacked in or on this side and probably flip it over, braze the bottom, and then turn around whatever angle we need to do the rest of it. But let's get going, getting some heat on this thing. We're going to start out by just gently heating things up. And once we get some heat in there, we'll start brazing. All right, so I think we got this brazed up. I'm gonna wrap this up and let it cool down real slow, and we'll come back probably tomorrow and finish this up. We got through with the brazing, and I haven't really cleaned anything up yet, but the first thing I want to do is I want to get this bottom milled flat. So I've got this clamped down. I've already indicated the base here, which was the original surface. To get it running true, it is clamped down. There's actually a piece that's perpendicular to this side on the bottom that I'm clamped down on top of. And we've got this set up in the horizontal mill, and I got a face mill over here that we're just gonna come across. And again, I purposely made these where they would stand up a little bit so I could mill it down flat and flush all the way across. And we're just gonna try to get as close to the original material as we can, original surface as we can, without taking off, you know, much more than a few thousandths off of it. So I've got my mill set up. I think we're running at about 412 RPMs. I'm gonna come in here and just kind of touch off. All right, I'm gonna count that as touching off right there. I can hear it hitting. We'll come out, and now I'm gonna bring my table in probably around 50 thousandths. Let me get an indicator set up to do that. This is going to be a 50 thousandths pass. Let me get my Slow this speed down. We'll start out with a 1-inch feed per minute. Now let's go up a little bit. We'll go up 1 3/4 inches. And that should be moving in there. Should be the last pass here. Just taking off about 4 or 5 thousandths. We are that last pass almost cleaned up all the way across, so I think this will get it. So there we go, we got a nice machine flat surface all the way across. You know, I probably got into the old material here by 3 or 4 thousandths, just barely fuzzed it. You can see where I V'd out here for the brazing job, and once we cleaned it up, all you have left is just those little strips down through there. But it's flowed all down in between that crack in there, and you got a good bond now. Next step here is we need to drill the holes in the bottom here, these ears. You know, here's our original one. Hopefully you can see that there, and you got the holes in there. So to figure out where these need to go, I measured on the sample I have here. They're 6.5 inches apart. And to get them lined up, what I did is I've just put a hole here to find where the first one goes. And I'm just going to measure off of that. And to find that, since I've got, again, the sample, we just butted these up together. I took a clamp on the other side, took a transfer punch and punched this side. If you look, I got a little dimple right there. And that should be lined up, you know, again, using the original one as a pattern. That should get me lined up where I need to be. So we're going to basically go in here and find the center of this hole on the mill, and then we'll drill it on the mill just like it's set up right now. I've got a drill chuck set up in here for drilling this out, and to find the center, I've just got a little pointer basically in here, and we're just gonna get over here and just kind of work our way around on the 3 axes until we get it lined up. And guys, I will tell you that, you know, this first hole, this is not a super precision. I mean, we're just bolting a casting down on a stand. It's very important that the holes be the correct distance apart, but if we miss alignment on this by, you know, 10, 15, 20 thousandths, it's not a big deal. It's not a big deal at all. This is just for bolting down. There's nothing precision that mates between them. So we've got a little bit of wiggle room here. I need to come up just a little bit. That is pretty darn close, and we're going to call it close enough. I'm happy with that. Even though we lined up on that hole with the center punch, I want to start out by just putting a a little center drill in here to just make sure I've got a good point exactly where I'm actually drilling. It should be pretty darn close to that center punch, but may not be perfect. So we're just going to come in here and touch off on that and get us a little dimple started for our drill bit. So we've got our drill bit in here. The size of the hole is 13/32, and we'll go ahead and drill this on through. So again, the distance between the center of the holes is 6.5 inches. So I need to move my table over, and I guess I could read the dial on the actual mill itself, but I just trust an indicator a little bit more. I just got this nice Federal 6-inch dial indicator, and this will be a good use for it. So I won't be able to do the whole distance in one move. I think I'll do 5 inches. Stop, we'll reset, and then do the last 1.5 inches. And I've just got this working off of a, kind of just put a little point down here on this end that I could indicate off of. So let's just go ahead. We'll go ahead and unlock the table here. And that's 100, 200. Let's see, I can keep track of my scale here. So that's 1 inch. That's 2 inches. We just go on out to 5 inches. Right there. So let me reset my indicator. Okay, let's go ahead and move our last 1.5 inches here. That's 1 inch, 100, 200, 300, 400, and 500 right there. I'll go ahead and put our center drill in here, spot it to get it going. That should be good. I always get comments on it, so I'm going to go ahead and say it again. The reason I'm not using oil on this is we're drilling cast iron. Cast iron has graphite in it. It's self-lubricating. Also, when you put oil on there, that oil splatters everywhere with that little fine cast iron dust that gets down in the ways of your machine, and it's like sandpaper. It will destroy the ways on your machine. So in working with cast iron, I do not use a cutting fluid. There's not a need for it. All right, there we go. So with that, we should be through doing the machining on this part. Everything is now in here. We got our 2 holes, bottom mill flat. We should be able to go ahead and take it out of the mill now. And the next step here is just go ahead, we're going to clean up the brazing job on here, probably do a little bit of grinding and whatever just to clean it up, make it look pretty, and I think we'll be done. So let's go ahead and pull it off. So I want you to see this chips we get off this. Yeah, there are some chips in here, but there is some ultra fine dust in there. That's very typical of machining cast iron. And again, you use oil, that oil gets down all over your machine, and you just can't get it up. Right now it's dry. I can come in here now with a shop vac, vacuum it right up. Now I'm going to clean up the whole machine with the shop vac. once that's done, I'll come in here with the rag, and particularly down here in my ways, I'm gonna just clean all this up, make sure we got all that dust out, because we don't want that grinding out in our ways and wearing the machine out. So kind of show you where we're at here. Of course, the bottom looks real good. Got our holes in there. I need to deburr those. I'll just do that little hand deburr. I did kind of come over here on the corners on the grinder and just kind of clean those up. It needed that not only for the braze, but also where the two parts made it together. They weren't just a perfect match. They were real close, but by me just knocking those off with the grinder, just kind of smoothed them out, so got all that done. The last thing I want to do is just kind of come in here. I'm going to take a little deburr wheel here on a die grinder, and we're just going to kind of massage that braze joint, since this is going to be exposed and seen, just to make it look a little bit nicer. I don't want to take too much of the braze out, but I do want to just kind of clean that up a little bit to make it a little less obvious that it's been repaired. I think we're about ready to call this project done. Like I said, I've come in there and I've just kind of worked over those rough edges a little bit with the die grinder. You know, we were just using this tool right here and carefully going in there and kind of grinding out the rough spots. And once that was done, I put it back in the bead blaster and bead blast everything. That's a little trick I'll do after I do grinding on a cast iron piece, is hit it with the bead blaster, and it just kind of takes out some of those grinding marks and puts a little bit of a texture back in here. You know, it's not quite the same texture as the cast iron, but it just, when you put paint on it, it really makes it look better than the texture you get from grinding. So anyway, this is ready to go back to its owner, and I think we're going to call it done. So before we close the video out, I do want to just address a couple of questions that I always seem to get anytime I'm doing brazing on cast iron. And the questions usually are, why didn't you just weld it instead of brazing it? Guys, cast iron doesn't weld very well. Can it be done? Yes, with nickel rods. There's even some newer stuff out there to use a stick welder or whatever. I like brazing. Brazing works for me. Been doing it a long time. I've gotten pretty good at it. I'm more confident with a brazing job than I am a welding job. And at the end of the day, I really just don't think it matters. A good brazing job is going to hold up extremely well. Why didn't I use TIG? Yes, you can use TIG. You can come in here with a silicon bronze or something and do that. And quite honestly, that's something I'd like to try. My problem is I don't have access to TIG right now. So when I get in my new shop, that's one of the things on the list, is to get a TIG set up. And I'm anxious to try. And basically with TIG, you're brazing. You're using silicon bronze, which is really the exact same thing that is a brazing rod. So you're just using a TIG torch to do that rather than using a flame torch. But you can control your heat a lot better with TIG. So anyway, that's something I want to try one day. Yes, I think it would work. But the main reason I'm using brazing is because that's what I'm comfortable with. It has worked very well for me. And I have no doubt that this repair is going to hold up for many years to come, probably forever. There's no reason why it should break. I have seen many brazed job repairs working on old machinery that have stood the test of time. So there's no doubt in my mind that brazing works. You know, the other big question I always get is using oil, and I think we've already covered that. Just, if you want to use oil on cast iron, that's fine. I choose not to, because I don't think it's necessary, number one, and number two, I just don't want to put the wear and tear on my machines. I always get dinged about that one in these videos. People say, why aren't you using oil? You're tearing up your tooling. Listen, I'd rather tear up a $1.98 drill bit than I would a $10,000 machine. So yeah, I'm not going to use any kind of fluid, coolant, oil, or anything like that on cast iron, except maybe in some unusual circumstances. But generally speaking, that's just not the way I'm going to go about it. So hopefully those two will answer some of your questions that I'm sure I'll get comments on anyway. With that, we're a wrap. So we'll get this part up to Jeff, who asked me to do this. It's been a fun little project. I'm sorry it kind of got strung out and stretched out, but he told me he wasn't in a big hurry. So, but I think this will be a nice repair. It'll look a lot better than what he had on here originally, which was a steel plate that was just kind of tacked on there with a weld job that really looked terrible. You know, can you tell this has been repaired? Absolutely. But it's going to look a lot more original with the cast iron ears on there, just like the original. And most people, once it's painted and cover up the color differential there, will never even notice it. So with that, thank you guys for watching. As always, please give me a like on the video if you like it. If you haven't already, please subscribe. We'd love to get new subscribers in here so you can watch other videos that we come down the pike. And leave me some comments. I always look forward to those as well. We'll talk to you later.